So this is Introduction to 3D Geometry, and this topic in this class we will be dealing with the basic properties of direction ratios and direction cosines, which are similar to what you have learned in class 11. And this 3D geometry is generally considered to be a little dicey topic for students, and I just need to reassure you that if you go about it in a systematic way, there is nothing difficult about it. On the contrary, it becomes very easy. So coming to direction ratios and direction cosines, you know that if OP makes angles alpha, beta, gamma, if a line makes angles alpha, beta, gamma with the positive direction of the x, y and z axis respectively, then cos alpha, cos beta, cos gamma are the direction cosines. So cos alpha, cos beta, cos gamma are the direction cosines, and alpha, beta, gamma are called the direction ratios. So remember, if a line makes angles alpha, beta, gamma with the positive direction of the x-axis, y-axis and z-axis, then alpha, beta, gamma are the direction ratios, and cos alpha, cos beta, cos gamma are the direction cosines. Again, some properties: cos squared alpha plus cos squared beta plus cos squared gamma equal to 1. And if L, M, N are the direction cosines of a line, then substituting here you get L squared plus M squared plus N squared equal to 1. Next property: direction ratios of a line joining two points x1, y1, z1, x2, y2, z2 is, you take the difference between both. Either you write x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. So either you separate it with commas or you separate it with commas and include these pointed brackets. This is a point you need to remember. Again, angle between two lines whose direction ratios are a1, b1, c1, a2, b2, c2 is given by cos theta is a1, a2 plus b1, b2 plus c1, c2 by root a1 squared plus b1 squared plus c1 squared into root a2 squared plus b2 squared plus c2 squared. This is a property which you also learn in vectors. And the acute angle cos theta is given by modulus of a1, a2 plus b1, b2 plus c1, c2 by root a1 squared plus b1 squared plus c1 squared into root a2 squared plus b2 squared plus c2 squared. So let's start with problems. Each problem is an adventure of its own. If a line makes angles 90 degrees, 60 degrees and 30 degrees with the positive direction of the x, y and z axis respectively, find the direction cosines. So direction cosines are cos alpha, cos beta, cos gamma, that is cos 90 which is 0, cos 60 which is half, and cos 30 is root 3 by 2, and as I said before, you have to enclose it in these type of brackets. Coming to question 2, can a line have direction angles 450? Let me just reduce the... Can a line have direction angles 45 degrees, 60 degrees and 120 degrees? So supposing a line has these direction angles. So cos 45 is 1 by root 2, cos 60 is half, and what is cos 120? That will be cos 90 plus 30. Second quadrant, cos is negative and we are on the vertical axis, so cos changes to sine, minus sine 30, that is minus half. And we use the property cos squared alpha plus cos squared beta plus cos squared gamma. That will give you 1 by 2 plus 1 by 4 plus 1 by 4, which is 1. So because cos squared alpha plus cos squared beta plus cos squared gamma equal to 1, such a line will exist. So having my years of experience teaching this topic, all I need to say is you need to master the formulas. So please write down the formulas on a paper and please go through it whenever you have time. Question 3, write the direction cosines of the z-axis. Now direction ratios of the z-axis are 0, 0, 1. Direction cosines will also be 0, 0, 1, because how will you find the direction cosines from the direction ratios? Just divided by the modulus. that is a by root a squared plus b squared plus c squared, b by root a squared plus c squared plus c squared, and so on with c. So in this case, the direction cosines is 1. These are all 1 mark questions or objective questions. So I hope by now you have crossed the threshold of basic 3D geometry and getting used to it. Question 4. A line makes an angle pi by 4 with each of the x-axis and y-axis. What angle does it make with the z-axis? So let the line make angle alpha with the z-axis, and it makes angles pi by 4 with the x-axis and y-axis. So I have cos squared pi by 4 plus cos squared pi by 4 plus cos squared alpha equal to 1. I am making use of the fact that cos squared alpha plus cos squared beta plus cos squared gamma equal to 1. So substituting for cos pi by 4, which is 1 by root 2, we get half plus cos squared alpha equal to 1. So cos squared alpha becomes 0, or alpha is 90 degrees. So I hope you are finding this understandable. And as I have said before, you need to take a pen and paper and pause each line and practice along with me. Coming to question 5, if a line has direction ratios 2, minus 1, minus 2, find its direction cosines. Again, a repetitive problem which we have done earlier. So direction ratios are 2, minus 1, minus 2. So if I take the modulus, what do we get here? You get root of 4 plus 1 plus 4, that is 3. And direction cosines will be 2 by 3, minus 1 by 3, minus 2 by 3. You have to divide each term by the magnitude. So as we said earlier, repetition is the mother of learning, so just keep practicing. And now we move into the deeper aspects. This is not too difficult though. Show that the line joining the points 1, minus 1, 2 and 3, 4, minus 2 is perpendicular to the line joining 0, 3, 2 and 3, 5, 6. So how will we do this? We take this line joining 1, minus 1, 2, 3, 4, minus 2, and here 0, 3, 2 and 3, 5, 6. First find the direction ratios of line 1. That will be minus 2, minus 5 and 4. You can go in any order. Direction ratios of line 2 will be minus 3, minus 2 and minus 4. And if we take the dot product of the two, we get 6 plus 10 minus 16, which is 0. So the angle is 0, so theta is 90 degrees. So the lines are perpendicular. So practice. The only way to learn maths is by doing mathematics. Coming to question 7. Find P and Q so that the line joining 7, P2 and Q minus 2, 5 may be parallel to the line joining the points 2, minus 3, 5 and minus 6, minus 15, 11. So we have the line joining these 2 points here, 7, P2, Q minus 2, 5, and the line joining these other 2 points also, that is 2, minus 3, 5, minus 6, minus 15, 11. Find the direction ratios of line 1, that will be 7 minus Q, P plus 2 minus 3. Direction ratios of line 2 will be, what will that be? You get 8, 12 and minus 6. And coming back to the question, you are given that the 2 lines are parallel. So because they are parallel, the direction ratios will be proportional. So I can say 7 minus Q by 8 will be P plus 2 by 12 equal to minus 3 by minus 6. That would give you 7 minus Q by 8 equal to P plus 2 by 12 minus 3 by minus 6 is half. If I just take these two together, 7 minus Q by 8 is half and P plus 2 by 12 is half. Solving, I get P as 4 and Q as 3. Again, a similar problem based on this. I hope you are able to understand. If you are not able to do so, feel free to send me a mail. Question 8. Show that the points 2, 3, 4, minus 1, minus 2, 1 and 5, 8, 7 are collinear. So you can try this problem. You are given the 3 points. I will call them as A, B, C. And first find the direction ratios of AB. That will be 3, 5 and 3. Direction ratios of BC will be -6, -10 and -6, and you are given that they are collinear, so the direction ratios are proportional. So 3 into -2 is -6, 5 into -2 is -10, 3 into -2 is -6. So everywhere if you multiply the direction ratios of AB by -2, you get the direction ratios of BC. So the direction ratios of AB and BC are proportional, so ABC are collinear. Now we come to the supreme ordeal, the more difficult problems of this topic. Find the angle between the lines whose direction cosines are √3 by 2, 1 by 4, √3 by 4 and minus √3 by 2, 1 by 4 and √3 by 4. So how will you do this? It's slightly different. A angle between two lines whose direction cosines are a1, b1, c1, a2, b2, c2 is given by cos theta is a1, a2 plus b1, b2 plus c1, c2. So in this case, using this property, your cos theta will be minus 3 by 4 plus 1 by 16 plus 3 by 16, which is minus half. And you know that cos 120 is cos 90 plus 30, which is minus sin 30, being in the second quadrant, which is minus half. So theta is 120 degrees. So your angle is 120 degrees. Now seize this treasure of this problem, which is not easy. The next problem. Find the direction cosines of a line which is perpendicular to the two lines formed by joining A 2, 3, minus 4 to B minus 3, 3, minus 2 and C minus 1, 4, 2 to D 3, 5, 1. So how will you do this? You are given A and B, C and D. So first find the direction ratios of the line AB. That supposing it is ABC. So direction ratios of a particular, you have to find the direction ratios of a line which is perpendicular to two lines. So let the direction ratios of the line which you want to find be ABC. This line is perpendicular to AB. What are the direction ratios of AB? 5, 0 and minus 2. So because this line is perpendicular to AB, dot product of the direction ratios is 1. So 5A minus 2C equal to, dot product of the direction ratios will be 0. So 5A minus 2C is 0. Again, direction ratios of CD is 4, 1 and 4 minus 1, minus 4, minus 1 and 1. And ABC, the direction ratios of the line which is perpendicular to CD will be minus 4A minus B plus C equal to 0, because the line having direction ratios ABC is perpendicular to this line. So we have two equations. First one is 5A minus 2C is 0. Second one is minus 4A minus B plus C equal to 0. We have two equations in three unknowns. So from 1 A is 2 by 5 C, and substituting in 2, we get minus 4 into 2 by 5 C minus B plus C is 0. So B will be minus 3 by 5 C, and direction ratios of your line will be 2 by 5 C minus 3 by 5 C and C. You can put C as 1 and multiply by 5 throughout. So you get 2 minus 3, 5. And you have to find the direction cosines of the line. That is 2 by root 38. The modulus will be root of 4 plus 9 plus 25, which is root 38. So direction cosines will be 2 by root 38 minus 3 by root 38 and 5 by root 38. So as you may, if you get tired of doing all these problems, I encourage you to pause and come back to where we have stopped. And now we are almost coming to the end of the journey. Again, this is a difficult problem which is a different type. Find the angle between the lines whose direction cosines are given by the equation 3l plus m plus 5n equal to 0 and 6mn minus 2nl plus 5lm equal to 0. So again, this is a different type. We start with 3l plus m plus 5n equal to 0 and 6mn minus 2nl plus 5lm equal to 0. Understand the direction cosines of the two lines are given by this equation. First you have to find the equation of the line. So from 1 we can write m as minus 3l minus 5n and substitute in 2. So you get 6 times minus 3l minus 5n into n, minus 2nl plus 5l times minus 3l minus 5n equal to 0. Simplifying, you get minus 30n squared minus 45ln minus 15l squared equal to 0. Divide by 15, so you get l squared plus 3ln plus 2n squared equal to 0. And factorizing, you get l into l plus 2ln. You can find two terms whose product is 2, sum is 3l. So you get l squared plus 2ln plus ln plus 2n squared equal to 0. Factorizing, you get l into l plus 2n plus n into l plus 2n equal to 0. That will give you l plus 2n into l plus n equal to 0. So l is minus 2n or minus n. Now if l is minus 2n, this is your m. Substituting for l, you get m is minus n, and direction ratios will be your lmn. So you have minus 2n, n and n. So you can divide by n throughout and you get minus 2, 1, 1. And if l equal to minus n, substituting here, what is m? M is minus 3l minus 5n. So you get minus 3 into minus n minus 5n. That will give you minus 2n. So your other direction ratios will be lmn. So minus n, minus 2n and n. Divide by n throughout, so you get minus 1, minus 2 and minus 1. So direction ratios of the two lines are these. Now you can find the angle theta. So cos theta will be 2 minus 2 plus 1 by root of the magnitude, root of 4 plus 1 plus 1 into root of 1 plus 4 plus 1, that is 1 by 6. So your acute angle is theta is cos inverse 1 by 6. So that completes this problem, and again this is a different type of problem, so please mark this problem. Coming to question 12, find the point in which the join of a minus 9, 4, 5 and b 11, 0, minus 1 is met by the perpendicular from the origin. So how will you do this? You are given 2 points a and b, and you have to find the point in which the perpendicular from the origin meets this line. So this is your line, and let this is a perpendicular from the origin, and we assume that let the perpendicular from the origin be p, and let p divide AB in the ratio lambda is to 1. This is section formula which you have learned. So using section formula, p is 11 lambda minus 9 by lambda plus 1, lambda plus 4, so you get 0 plus 4 by lambda plus 1, and minus lambda plus 5 by lambda plus 1. And your direction ratios of OP, this is your O as origin 0, 0, 0. So direction ratios of OP will be same as this. And direction ratios of AB will be subtract the two, 20 minus 4 minus 6. The two lines are perpendicular, so if you multiply the two direction ratios, you get 0. So you get 20 into 11 lambda minus 9 by lambda plus 1. Minus 4 into 4 by lambda plus 1 minus 6 into minus lambda plus 5 by lambda plus 1 equal to 0. Solving, you get lambda is 1, and now you substitute here for lambda is 1. So your point of intersection will be 11 minus 9, that is 2 by 2, which is 1, 2 and 2. So we have come to the end of this topic on direction ratios and direction cosines of 3D geometry. This is the first part of 3D, and I've almost covered the first exercise. So in the next class, we will be dealing with equation of a line in 3D geometry. Thank you.